Alright guys, it's HitraN here, the unnecessary programmer. I was sitting there yesterday just chilling and I was wondering if we can overcomplicate even the simplest of programs so we can secure our position for eternity at our current job. Turns out, yes, I was able to turn this simple program that's just adding the two numbers and printing the sum into this beauty. 90 lines of pure job security source code. So, if you want to join me on my quest of writing the simplest Python program in the most complicated way that I can, stay tuned and let's dig into the idea itself. As a programmer myself, even an unnecessary one of course, I must say that design patterns are something very useful. Design patterns are solutions to general problems that software developers face during software development. These solutions were obtained by trial and error by numerous software developers over quite a substantial period of time actually. And today we are going to abuse all the coding sweat and misuse the hell out of the command pattern of course. Because you know there can be too much of a good thing. In order to make this video a little bit educational, let's briefly explain what the command design pattern is. Because we want to use it the correct way, so we can pass our code reviews of course. But you know that a programmer sees a pull request of 6 lines of code and finds 10 problems, but when he or she sees a pull request of 90 lines of code, then oops, it all looks good, let's merge it. So lazy. Anyways, the command pattern is a data-driven design pattern and falls under the behavioral pattern category. A request is wrapped under an object as a command and passed to the invoker object. Invoker object looks for the appropriate object which can handle this command and passes the command to the corresponding object, which executes the command itself. Essentially, we need the command interface and a command implementation class, which accepts a receiver object that does the actual job of the program. We can have as many receivers as we want. Every object can handle a different piece of code or different functionality. Which receiver should be used can be decided even at runtime if the software itself is more complicated. In our case, we are going to have only one receiver and the invoker will pretty much know exactly which object to pass. Enough with the explanation, let's hope I didn't bore you to death. Let's see the code and don't forget to write as many comments and over-explain everything. It adds much needed confusion to see a lot of comments that are quite unnecessary. Also, it fluffs up the script up quite a bit. Smooth. Next, let's add the data transfer object or the DTO, because what are we, noobs? How can we just pass two numbers to the receiver? We need to pass an object of course. While I was writing this part, a brilliant idea came to my mind. Let's also add a builder to the setters. This means we return the same object as a return type of all the setter methods, so it can use functional programming to set only the needed fields. This will make a lot more sense if we have more than 2 fields in our class, but oh well, this is the general idea after all. Confusion. To be honest, at this point I was running out of ideas and I kinda needed to complicate the receiver logic itself, because after all it was still the same easy program. Whoever reads our script can still pretty easily spot the key place where all the magic happens. So I decided to do the calculation of the numbers in hexadecimal numeral system, of course. There is a hex function built in Python, so we don't have to write a lot of additional code, but it will also secure the complexity of our action method. Well, I think this is quite enough. I'm even pretty sure that if I see this script after 2 or 3 months, I will have no idea what in the world is happening here. Of course, let's run it to make sure it works as expected. Thank you everyone for watching. I really hope you enjoyed this quick little silly video, and of course, see you in the next one. Bye!